guys, welcome back to the series of tutorials on C++. I am Deepak Kunyal. In the previous video, we were discussing about the STL and specifically associative non-linear containers. Now one container is left to discuss, and that is container adapters. So let's begin with that. So container adapters are basically constraint version of sequential containers, or you can say that they provide a different interface for sequential containers. So example of these type of containers are stack, queue, or priority queue. So now let's discuss about these containers and their functions. So the first thing that I am going to discuss here is stack. The stack container is used to replicate stacks in C++, and for this insertion or deletion both are done at the top of the stack. So if you want to implement stack in STL, you have to use something like this stack, then data type for which you want to create stack, and then stack name. And it is similar to other containers that we have discussed till now. You have to include a header file for using this container which is named stack. So it's not that difficult to guess at this moment, I think. Now we have some functions that we are already familiar with in the stack. So one is push. Push function insert element in the stack, and the element are inserted at the top of the stack. Other function that we have in stack is pop function, and it will remove element from the top of the stack. It will basically reduce the size of stack by 1. The element is always removed from the topmost element of the stack, or you can say that the most recently added element is removed from the top, but this method does not return anything. Then there is another function which is top function. This method returns the topmost element of the stack. One thing you can note down here is that this top is returning the element, but pop is removing the element. And this is the difference between these two methods, right? And as this is removing the element from the top, or we can say the latest element that is added in the stack can be shown something like this. So suppose we have 1, 2, 3 and 4 added at the end. So this will be the removed first element. Or we can say that this acts as last in first out. Right? Now we have some other methods like size and empty in the stack. Size will return the number of elements, right? So these are the number of elements present in the stack, whereas empty checks if stack is empty or not. So it is going to return if stack is empty, otherwise it will return false. Another function that we have in stack is swap, which swaps the element of two stacks, and you can use syntax like this where S1 and S2 are two stacks. Similarly, you can create queue and priority queue using following syntax and manipulate them using their inbuilt functions. So you can declare the queue using following syntax. It is similar to declaring stack, and you can include a queue header file. The queue container is used to replicate queue in C++, and its insertion always takes place at the back of the queue, and deletion is always performed at the front of the queue. So we are not going to discuss this in much detail, but following functions are used in queue, and these are similar to some other containers that you already know. You can try exploring these functions on your own, and if you find any doubt or query regarding any of these things, you can write in the comments. Now I am going to talk briefly about priority queue. So when you are declaring priority queue, you have to write priority queue, and you can use header file has include priority underscore queue. Then you have to use the similar syntax of declaring priority queue, then name of priority queue here. Priority queue is just like a normal queue that we have discussed here, except that the element removed from the queue is always the greatest among all the elements in the queue. And thus this container is usually used to replicate maxip in C++. So I hope you have heard about this. But if you have not heard about this, don't worry. This is basically discussed in the DA, or we can say design and analysis of algorithm course. So element can be inserted at any order and it will have a complexity of O log of n. So it's a complexity for insertion. And we are not going to talk all these things in much detail because it's going to be a lot of material for you to digest at this moment. There are some functions like push, pop, front, back, and I'm sure that you know the meaning of all these functions till now. So you can see that it's easier to understand STL because we are using almost same function in all the containers, right? Their functionalities changed a bit, but that doesn't matter much because when you are in practice you will know what to use at what place. All right, I hope you are clear with the stack queue, priority queue, and this discussion. We are going to implement all these things in detail in coming tutorials, but as of now understanding concepts is the thing that we need at this moment. So this is it about container adapters. I think we have discussed a lot of things till now, and most of the things are similar. So I hope you can, or if you know about these data structures previously, you can easily implement them. All right. Although I will implement some of them in later part of these tutorials, but till now you should be able to understand all the details about the containers or algorithms or iterators. So there are many of the things that are still left, and we are going to cover these things in next tutorial. So guys, if you have any doubt or query regarding any of these things till now, you can write your queries in the comments and I will try to respond back as soon as possible. So see you in the next video with some new concept. Till then, thank you so much.